leaning is pretty similar to the sprint, but not so similar. Let's create our variable function, local action lean equals to just that string. So of course we only want to be able to lean if we're moving, so we could bind the lean action. And if I were to go, because there's two lean directions, right? So if I were to go A and then D, the D would bind over A every time. So I can't just bind two actions, two key binds to the same action like that, because there's priorities here. Instead, what I could do is in our bind action update it so it can take multiple key codes. Now my idea is I send a table with the key codes I want in the bind action function, right? If the key is a table, then I return n, there's no point in continuing. And just so it remains a key, I'll create a new table called keys and loop through each key in our current key table. And what I'm essentially trying to do is create a copy of this key table, but instead converting our strings into key codes, into like enum the key code dot the string. This allows us to send it in string form too. And now that it's here, I could copy this, paste it here. Instead of sending the enum the key code the key, I could actually just unpack the table. And what does unpack does? So let's say the first parameter of our table is enum the key code the A, second parameter is enum the key code the D. It would go enum the key code the A, comma enum the key code the D. And in doing so, we can also bind multiple keys to the same function. Now we've updated our bind action. We've also sent it here. Every time we lean, we should know with the action lean. And just so we keep up, I'll unbind the action when we stop moving. Action lean. Using the exact same method, I'm gonna actually create the function in the lean, like, you know, outside, because, you know, spamming functions. So lean equals function. And if the lean is fired, then let's just print leaning. Heck, let's print which key we're pressing. I activate the skill. I press D. And absolutely nothing happens. And I'm starting to wonder why. It's simply because we didn't actually set the action name with the function lean. So let's set the action name, which is action lean, with our function lean. And now let's test again. I lean to the right, pressing D, it activates D. I lean to A, perfect. But now we want to know if we're leaning to the right or the left. And we can do this quite perfectly using the exact same method. I know, I love it now. And go local lean direction equals, so which direction do we want? If it's enum the key code dot A, then we're leaning to the left. However, if it's enum the key code dot D, then we're leaning to the right. And if we were to print lean direction, input the object the key code, it should tell us left or right depending on which key we're pressing. Let's go ahead and test that. I lean to the left, it shows left. I lean to the right, it shows right again. Perfection. Now my idea is to send over during the loop stage a table. This table is called leaning. Now this table is an empty table, but if we were to lean, it shows us if we're leaning. So if we're leaning, then it will be leaning bracket right equals true. If we stop leaning to the right, then it will be nothing. If we're leaning to the left, it will be leaning bracket left equals true. So let's go ahead and program that. So right here, we already know with the directions. So our new very cleverly named variable is called direction. And it either gives us left or right depending on where we're leaning to. We can just go ahead and set leaning bracket that direction to true, but we only want to set it to true if we're actually leaning in that direction. So if we're holding it down, so if input began equals true, I just thought of something new. So if we are holding it down, then we can set it to the input begin. So this will be true, but if we're not, then it will be like we're not holding down, so that will be false. Let me explain more slowly. If we're holding the right car, it will be lean bracket right equals true. The second we let go, it will be leaning bracket right equals false. We can go ahead and print this. Because it's not a list, we can't do print.unpark, but what we can do though is iterate through everything in the leaning and print I, v. Let's go ahead and test this. I lean to the right. As you can see, it's showing the right true. Now it's right false. I lean to the left. As you can see, it's showing left true but right false. And now they are both false. But if I lean in both directions, you see they're both directions are showing true. So now we have the direction we're leaning in. That was pretty nice and easy. I actually just came up with this a little bit right now. Proud of myself. So continuing, so we have the directions we're leaning in. We found the action. Before we go actually do stuff in the server, let's make sure that if we're leaning in the direction before we activate skill, it actually recognizes that we're leaning in that direction by just going check key pressed with the A and check key pressed with the D. I'm not gonna lie, I did do this in a more optimized way, but the more optimized way took about 6 more lines of code, so I'm gonna leave it like this. So now we have the function to file. What will be our function? We'll call it set leaning. I never fail to deliver. Set leaning. So set leaning equals function. For this function, we actually do need the key. We're gonna update our check key pressed. The second parameter we're gonna fire is the input object.keycode. Now, we don't really care about the first parameter, but the second parameter, key, is what we care about. So doing the same thing, just set leaning to the lean direction, bracket the key, equals true. So it'd be like lean direction, so this would be like either right or left, and to be right or left equals true. And finally, we set the function. So set leaning, remove the squiggly, remove the regular brackets, set leaning, remove the regular brackets, and just so we can test it out to make sure it works. Before I activate skill, I'm gonna be moving right. Maybe I might wanna, okay, now I'm moving right to activate the skill, and it's saying left equals true. I let go, and perfect. Now the server officially knows if it's left or if it's right. Let's test that. We're not gonna create a new broomstick function, but use the current looping function. Where's our looping function? But use it was so small I didn't recognize it. But you use the current looping function. So right here we can use these things, and I'm not gonna lie, I'm not sure what they're called. I just saw them in a tutorial from this really smart dude. I think his name was Def King. He's amazing. And it's basically the three dots. So whatever variable, for every variable you put, it's stored in these dots. So everything after loop would be stored in those dots. So if I had D, S, they'll all be stored in those dots. And I'm doing this because it's starting to get a little like messy, like 1, 2, but 3 is pushing it. So how do we get those? How do we get what's stored in those dots? Well, we put them in a table. First I don't know what it's called, and I can't remember its name, but the eye on the table, the first part of the table would be like our first variable. The second would be the second variable after the string leen, and so on. So since local leen is variable 1, we have the leaning, and then we can get a right or left. So let's do it the other way, left or right. And left or right is just leen bracket the string left, comma, the string right. We can go ahead and check if left or right then we are leaning. Perfect. And when we're leaning, we want to not only rotate our body in the direction we are, and I quote, leaning in, we also want to move ourselves just a little bit in that direction. Not too much, just a little bit. So how do we do this? Well, I will create another variable called additional leen. This is for the velocity, by the way. And right now it's a vector3.0 because vector3s and numbers can't add, but it can perform multiplication and division. So of course we can go, if we're leaning to the left, then we move a little bit to the left, else we move a little bit to the right. And how do we do this? Well, we change the additional leen to the humanoid root part .cframe.right vector. So gonna multiply by a negative to make it left vector, because there is no left vector, just right vector, times, let's go, speed.value divided by 10. Nothing too high, just a little bit. And of course, to make it lean to the right, just add the positive. And if I go ahead and test this, you should notice a slight lean in the direction I'm moving. So I activate the skill. I'm leaning. Okay, well, I move kind of fast, I just realized. So I'm leaning to the left, and I'm leaning. Okay, maybe I should stop printing. It's getting kind of annoying. I'm leaning to the right. I'm leaning to the left, the right. And as you can see, I'm moving to the right, to the left, swerving through the world. Easy, didn't even have to rotate my screen on that one. I'm just a leaning champion. But there's an easier way to do this. There's a more optimized way to do this. I'll show you. So if we're leaning in the left or right direction, we just automatically assume we're leaning in the right direction. Why? I just chose a random one, honestly. The one without the negative. But if it turns out we were wrong, we were actually not leaning in the right direction, but in the left direction, then we just make the additional leen negative. However, if we're leaning both in the right and the left direction, so I'm going to put this in squiggly brackets. So if left or right, and we're not leaning in, if we're leaning in both the left and the right direction, do nothing. So if we're not leaning in both the right and the left direction at the same time, then continue. This is my weird English math that I came up with. Let's go ahead and test it with more obvious leans. So maybe I'll divide this by 2, just so we can notice it more. The lean master here, literally swerving through existence. I lean to the right, I lean to the left, right, left, and now I hold both at the same time. And now I'm going straight. I let go of one key, and I automatically start leaning in that direction. I hold both at the same time, I'm straight. I let go of one key, and I automatically lean that direction. And I let go of both, I'm no longer leaning. If I am leaning, and I let go, then I stop moving. And if I start leaning, and if I am leaning before I start moving, and I move, I am leaning. Yes, I'm very sorry for confusing you guys, but the point is, it works. Take a moment to cool your brain. I've been at this for like an hour and 30. I'm tripping now. But what we must do. Now, to better control the align orientation so we can control which direction we're leaning, let's transfer the align orientation to the server. So simply just go fan mode, align orientation, right under linear velocity. Not that linear velocity, this linear velocity. And you can go ahead and rename it like we did for linear velocity, but I'm not too worried about that. So I'm going to go local align orientation equals humanoid root pod colon find first child align orientation. And of course, I'm going to destroy the align orientation, just copying linear velocity now, if it does exist. But on the side note, while I am that guy, as you can see, we repeated this thing so many times. As a quick way to optimize this, we create a table for all the items we want to destroy. So that's the broomstick, the linear velocity, and the align orientation. We swiftly loop through that table for IV in pairs. Items do. And for each item in this table, if said item does indeed exist and we're not being scammed, then we do scam the scammer and destroy said item. Done. An optimized way to destroy everything. Said the devil himself. But now we move down to additional lean right here. So if align orientation, then we've already created and destroyed. All that's left is to set its C frame. But if we would notice one thing, it's that the mouse to hit position, we don't have the mouse position. So let's quickly send over the mouse position. We can send more than messages here. So our third parameter would be mouse to hit position, just to make life a little easier. And of course, the local mouse position would now be variables, bracket the second one. So now, right hand mouse to hit position, I can just replace that with mouse position. And we are gonna test this just to make sure it works. Wait, what was I testing? Oh yeah, rotation. I forgot what I was testing. Yeah, it is working perfectly fine. Now let's add the lean. How do we add the lean? Very simple. Doing the exact same thing. I'm just gonna add a comma and call this rotational amount. I was 2 months old, 2 months younger when I came up with that variable. No judging. And we'll set it to 0 and show value. And then we can multiply it by C-frame the angles. And since the place we want to rotate is not in the X, it's not in the Y, but it's indeed in the Z, I'm going to convert our angles, because we're taking in angles, to radians, because I don't think in radians, and then rotate it by that much. Now just to test the rotational amount, we can set this value to 5. Okay, maybe 5 might be too little, but just show you, that'll be 5 degrees in angles. So I activate it and I'm 5 degrees tilted. You may not notice, so I'm gonna set us to 45 degrees tilted to make it more obvious. I activate skill. I am 45 degrees tilted. And if you notice, I am tilted not along the broom, but actually at the center of my mass, my humanoid root pod. Now I really wanted to tilt this along the broom so much, but I couldn't just find a way to, because the align orientation only applies only at the center of mass. So I decided to just be satisfied with this. Of course, I forgot to make this back to normal. So whatever lean works best for you. In this case, I'm just gonna set its rotational amount. And 10 works best for me, so 10 when it's moving at a regular speed. And since I want the rotational amount to be way more when we're sprinting for that dynamic feel, what divided by 200 makes 10? 20. So I'll divide the speed value by 20, so it's really dynamic. And I'm pretty sure the negative rotation, so if we're rotated in the opposite direction, it makes us feel like we're leaning in the right direction. The rotational amount, of course, if it's left, would just be negative rotational amount, like so. And if we were to test this, before we continue, before you guys start leaving the video saying thank you so much, Josh, there's one thing I did forget. There's probably a couple more things, but to reset the lean direction when we stop moving. So if move equals to false, then lean direction equals to a new table. I activate the skill. I lean towards the left, and ooh, what you guys look, so beautiful. And it looks nice. It's just a little bit of a lean, just add some spice to the already beautiful thing. So now I start sprinting and I lean, and as you can see, I am pretty sure that's what, a 27-degree angle. Yeah, pretty nice. And like that, we are done. I'm so glad you watched. Thanks for watching. I can't wait to see you guys in part 3, the next video, where we really get into the good stuff, the visual effects, and trust me, it's gonna be wow. So see you in the next one. Thanks for watching. Bye.